Hey everyone, welcome to my video editorial of Codeforces Global Round 26. There will be hints throughout the video, and I will be explaining the thought process behind solving the problems, so hopefully you guys will have a better idea on how to solve the problems, and don't be afraid to pause after a hint and think more about a problem. In problem A, we're given a sorted array and we want to color it into red and blue, such that the range of the red elements does not equal the range of the blue elements. Range is equal to the max element minus the min element. For example, by assigning the second and fourth elements of the array shown above to be red and the rest blue, the range of the red colors is 3 minus 1 equals 2, and the range of the blue elements is 4 minus 1 equals 3. So let's try to think about how we can minimize a range. We can accomplish this by only having one element of a specific color, and when we do this, the range becomes 0. And also, let's think about when it's impossible to solve the problem. For example, let's look at an array of all equal elements. Both of these ranges will always be equal to 0 no matter what we do, so the problem becomes impossible then. How can we use both of these to solve the problem? So first of all, we can check to see if the array is equal by comparing the first and last elements. Because the array is sorted, if the first and last elements are equal, the entire array is equal, so the problem is impossible. Then we're gonna color the array using this pattern. The second element will be red and all the other ones will be blue. Using this, the range of the blue elements will be equal to 0, and the range of the red elements will be the range of the entire array, which is greater than 0. So in problem B, we have large digits, but what is a large digit? Any digit between 5 and 9 is considered large. A large number is a number only consisting of large digits. For example, 5675 and 99999 are both large numbers because all their digits are large. However, 120304 is not large because none of its digits are large, and 56745 is not large due to the digit 4 not being large. Our problem here is to determine, for a given integer x, can it be the sum of two large integers with the same number of digits? For x equals 135, it can be the sum of the two large integers 67 and 68. However, for x equals 233, there is no solution. Hint 1 is to see what happens when we add two large digits together. By adding 5 and 5 we get 10, and by adding 9 and 9 we get 18. So the sum of our numbers has to be between 10 and 18. And hint 2 is to think about how carrying digits affects the problem. So let's look at an example. Here we can notice that due to both digits being larger than 5, during the addition of every digit, a 1 is always carried. This means the first digit of x has to be a 1. So what properties are needed for x to be valid? Firstly, the last digit cannot be a 9. During the first hint, we notice that during adding any two large digits, the number is between 10 and 18, and none of these numbers between 10 and 18 have a digit 9 in them. And secondly, as we discussed in part 2, during the addition of every digit, there's always a 1 carried. Due to this, the first digit of the answer has to be 1. And finally, combining our two observations, the ones place is always between 0 and 8, and there's always a 1 carried during addition. So this means that each digit between the first and the last one is between 1 and 9. So none of these digits can be 0. Let's look at how to code this. We can input our integer as a string and set a boolean variable to see if any of the conditions are violated. We first check to see if the first digit is not a 1. Then we iterate through the middle digits to see if any of them are equal to 0. And finally, we check the last digit to see if it's equal to 9. And if any of these are met, we output no, and otherwise we output yes. In problem C, we're given an array of size n, and the variable c that's initially 0. We go through every index of the array in order and choose one of two operations. We either set c equal to c plus ai, or we set c equal to the absolute value of c plus ai. For example, for the first index, we can set c to be either 0 plus 2 or the absolute value of 0 plus 2. In this case, it's the same, but let's look at the next index. We can either set C to be 2 minus 5 or the absolute value of 2 minus 5. We can see with the optimal operations, C can be at most 8 after all n operations. Our question here is, what is the maximum value of C we can obtain after all operations? Let's think about where we should choose option 2. Our claim is that we should choose option 2 at the prefix minimum, and let's see why we should do this. We attempt to take option 2 at index 2 and C becomes 3, and after we add the next two indices, our C goes down from 3 to 2. However, if we took option 1 at index 2, then took option 2 at index 4, C ends up being 4. This is because by taking option 2 at a negative number before the prefix minimum, the number could have gone down even more before taking the absolute value. Waiting for the number to go down even more than taking the absolute value will result in a larger value than taking the absolute value beforehand. Therefore, we should take the absolute value at the prefix minimum. How can we implement this? We can iterate through all prefix sums, and if we find a prefix sum less than the minimum one, we can mark that index of the minimum prefix sum. Then we can go through the elements again, and we add our elements to the answer, then take the absolute value at that index. Let's go on to the second subtask of problem C. In this subtask, we have to find the number of ways to maximize C at the end of all the operations. First hint is to think about when we can pick either option 1 or 2, and the answer will be the same. The only time we can pick either is when C plus AI is equal to the absolute value of C plus AI, and this only happens when C plus AI is non-negative. When will C be non-negative? Firstly, the most straightforward way C will be non-negative is if the prefix sum is non-negative. However, the case that is harder to spot is anytime after the prefix min, we can choose either because C will be non-negative. This is because due to the index being the local minimum, every other prefix sum after it will be equal to or greater than it, never being lesser. So we always have the option of picking either. Let's look at the array on the screen now. Both the first and the second prefix sums are non-negative. However, the third index is a prefix minimum, and there are 2 elements after the third index. So there are a total of 4 indices where we can choose what operation we want to do. Therefore, there are 2 to the 4 way to choose these. Let's move on to the 4th index. The 4th prefix sum is also non-negative, and the 5th prefix sum is a prefix minimum. Here there are no elements in front of it, and 3 non-negative prefix sums before this index. Therefore, there are 2 cubed ways of maximizing C when index 5 is the first prefix minimum where we perform operation 2. Adding these up, there are 24 total ways to maximize C. Let's try to code this up. First, let's generate the powers of 2 to use later. Then we iterate through all the prefix sums to find the prefix minimum like we did in the first subtask. Let's iterate through all the elements again, and if the prefix sum would be non-negative, we increment the pre-count variable. Then we check if we are at a prefix minimum. If we are, we add 2 to the power of the number of elements we can choose from. The number of elements we can choose from is the pre-count variable we defined earlier, and the number of elements after the current one, which is equal to n minus I minus 1. After we add these all up, we get our answer, and then we also handle a special case where there's no negative prefix minimum, and then the answer would be 2 to the n then. Well, that was it for the video editorial. I thank you all, and this was done on a pretty short time frame, so the quality could be a little better, but still thank you all, and I hope you guys enjoyed this.